I'm sitting in the car right now at the gate to the school because my clicker isn't working. So at some point in this video, I may just have to pause at random and drive onto campus. But I figured I might as well get this lesson started. So this is an introduction to power series, and I think I want to start by just kind of trying to give you an idea of what a power series is. And sometimes I like to think that the best way to think of what a power series is that it's kind of like an infinitely long polynomial. And it's not really precise at all, but I mean, if we have a polynomial, let's say we've got p of x is 1 plus x squared. I mean, this is a second degree polynomial, right? Because its highest power is 2. It's a second degree polynomial, not a big deal. A power series, on the other hand, might look like 1 plus x squared plus x cubed plus, and so on. For our purposes, there's always going to be a pattern to them. Like, you're always going to be able to tell what the coefficients are. In this case, the pattern is really boring. It's just a 1 plus 1x squared plus 1x cubed plus, presumably 1x to the fourth, 1x to the fifth, and so on. And so oftentimes, they'll write them in sigma notation. They'll say this is the sum from n equals 0 to infinity of, and what is this? Well, this is basically x to the nth power, right? and there we go, our first example of a power series. Now, another very important thing that I should mention is that power series are always centered somewhere. And so if you remember from what we did with Taylor polynomials and Maclaurin polynomials, you can generally tell what the center is by looking at the x terms. So, for instance, let me write down another power series. Suppose I had the power series 1 plus x plus 2 plus x plus 2 squared over 2 plus x plus 2 cubed over 6, and so on. So, and maybe I should take a minute to convince you that this is a power series. I said before that they were supposed to be like infinite polynomials, and when you look at this, you may not feel like this really looks like an infinite polynomial. You guys are used to seeing x to the first, x squared, x cubed, not like x plus 2, and then x plus 2 squared, and x plus 2 cubed. And just, you're never going to have to do this, but I want to point it out to you. If you were to FOIL this out, and FOIL this out, and FOIL out the fourth power term, and the fifth power term, and so on, you could simplify it, and you could get a more traditional-looking polynomial type thing. What's important about this one is because they all have x plus 2 in them, that tells us that the center of the power series, the center will be x equals negative 2. And again, that's probably something that you've seen before, and I hope you recognize it. It's just this idea that when there's an x plus 2, it's centered at negative 2. If it had an x minus 3 for all of them, then it's centered at x equals positive 3. We saw that with Taylor polynomials and Maclaurin polynomials. It's the same thing. I might as well give the sigma notation for this as well. This would be the sum on n equals 0 to infinity. And if you're following this at home, it may actually be worth pausing the video for a minute and thinking about what it is. And I'll sort of give you a hint. It should be x plus 2 to some power over something. So try that out. So I'm seeing this as x plus 2 to the nth power over n factorial, right? So these are power series. That's what a power series is. And I kind of think that's all that I need to say in this video. I might as well intro the next video. The next thing that we need to discuss is, so these are series. These are infinite series. Do these series converge? And the answer is a little bit complicated. The answer is that it depends on what x is. And I'm not going to say, like, oh, well, if x is too big, then it's not going to work. It's dependent on each series. Every series is different. And so, depending on the other things, we have to look and see when will this thing converge. The one thing that I can tell you is that a power series will always converge at its center. And I'm actually going to write that. So there we go. A power series will always converge at its center. Whether it converges for other values of x or not will be covered in the next video. And again, I sort of want to point out why that makes sense. Take a look at this one, right? What's the center of that power series? Keep in mind that the center of this one was -2. Because the thing that was repeated here was x plus 2, x plus 2, x plus 2, the center was x equals -2. The thing repeated here is x, x, x. It's almost like it's x plus 0, which is what tells us that the center of this one is x equals 0. So imagine what would happen if you plugged in 0 for all of these x's forever. Can you tell what this series would add up to? It's 1 plus 0, 0, 0, 0, 0, 0, 0, 0, 0. It seems pretty clear that this power series converges to 1 if you plug in the center. Right? For my next example, what would happen if I plugged in, now this is actually interesting, what would happen if I plugged in 0 for all of these? You're like, that's complicated, I don't know. But what's clear is that if I were to plug in the center of -2 here, 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 and all of them, all of these things turn into 0. And so it's clear that this power series converges at its center because the center turns every term into 0 except maybe the first term. Right? So long story short, a power series will always converge at its center. Anywhere else, it's going to take a little bit more work, and I will cover that for you in the next video.